This is the fourth section of Industrial Hydraulics module number 2. Last section we have discussed about up to piston pump. In this section, starting with discussing performance curve for positive and non-positive displacement pump. See, positive displacement pumps are commonly used in the industrial hydraulic circuit applications. Positive displacement pump, which is also known as hydrostatic pump, the pump will produce high head, low discharge. Non-positive displacement pump are also called hydrodynamic pumps. Hydrodynamic pumps are low head, high discharge pump. That's why it is used in household applications. See, what is the difference between a positive displacement pump and non-positive displacement pump in the point of view of performance? So first point, the flow rate does not change with the head in the case of positive displacement pump. Non-positive displacement pump, flow rate decreases with the head. So you can see that the graph, that is in the case of positive displacement pump, the flow rate does not affect with the change in head. When the head increases or decreases, it does not affect the flow rate. But in the case of non-positive displacement pump, like a centrifugal pump, when the head increases or otherwise, the flow rate decreases with the decreasing head. So when the head decreases, flow rate decreases. When the head increasing, flow rate increasing. Okay, so that's the first point regarding flow rate. And second point, the flow rate is not much affected by the viscosity of fluid in the case of positive displacement pump. The flow rate decreases with viscosity in the case of non-positive displacement pump. So this is the viscosity head graph. So in the case of positive displacement pump, the flow rate is not affect the viscosity. It will be constant. But in the case of non-positive displacement pump like centrifugal pump, when the viscosity increases, the flow rate will be decreases or head will be decreases. Third point is efficiency is almost constant with the head. In positive displacement pump, efficiency increases with the head at first and then decreases in the case of non-positive displacement pump. So in the case of positive displacement pump, the efficiency will be almost constant with the head. But in the case of non-positive displacement pump, like a centrifugal pump, the efficiency will be first increases when the head is increasing, and at a particular value it will be come to decrease when again the head increases. So these are the 3 points, the 3 points regarding positive displacement pump and non-positive displacement pump. So once more, the flow rate does not change with the head. The flow rate decreases with the head. Flow rate is not much affected by the viscosity of fluid. Flow rate decreases with viscosity. Efficiency is almost constant with the head. Efficiency increases with the head at first and then decreases. Next, comparison between gear pump, vane pump and piston pump. This is a very important topic. Usually asked as a essay question in university examinations. Comparison between gear pump, vane pump and piston pump. So we have gear pump, vane pump and piston pump. So first one based on construction. Gear pump. It consists of 2 gears in mesh with each other mounted inside a closed casing. One is driver and other is driven gear. So this point is regarding gear pump. Vane pump, it consists of a cylindrical rotor with radial slots. Vanes are inserted in the slot. The rotor is mounted with an offset in the casing. Regarding vane pump. Piston pump, it consists of cylinder block with axial or radial bores. Pistons are inserted in the bore. One end of the piston is connected to the rotating component. So these all points are regarding the construction of the gear pump, vane pump and piston pump. Next one, working. First of all, gear pump. When the driver is rotated by means of any prime mover, driven will also rotate. Thus, oil is sucked, trapped between the gear teeth and casing, carried from inlet to outlet. So this is the working of gear pump. Then vane pump. Rotation of cylindrical rotor causes the size of the pocket to grow continuously on one side and to reduce on the other side. This causes filling of oil on suction side and delivery of oil on the other side. So this is the working of vane pump. Piston pump. Rotation of the moving component causes the piston to reciprocate in bore. Half rotation of the cylinder block causes suction of oil into the bore and the next half causes discharge. So this is the working of piston pump. So these all we are discussed detailedly in this section. We are discussing each pump. Okay. Then third one, pressure, discharge, speed and volumetric efficiency. First points are gear pump. So gear pump, pressure of 35 to 200 bar, discharge up to 45 meter cube per hour, rotational speed is 1200 to 2500 rpm, volumetric efficiency is 80 to 90%. So in the case of vane pump, pressure up to 70 to 140 bar developed, discharge up to 20 meter cube per hour, rotation speed is 1200 to 1800 rpm, volumetric efficiency is 90 to 95%. In the case of piston pump is pressure produces 140 to 850 bar, discharge is up to 45 meter cube per hour, rotation speed is 1200 to 3000 rpm, volumetric efficiency is 95 to 98. So for piston pump, the volumetric efficiency is maximum and the gear pump, the volumetric efficiency is minimum. So this is a comparison between the gear pump, vane pump and piston pump. Okay, this is a very important question. Usually in university examination, we'll ask, explain the comparison between gear pump, vane pump and piston pump. You have to answer in this manner based on the 3 points, that is construction, working and pressure, discharge speed and volumetric efficiency. Okay. So next one is pump performance. So in this section, I am going to discuss about what is the definition of volumetric efficiency, mechanical efficiency, then overall efficiency of a pump. Okay. So first one, mechanical efficiency, volumetric efficiency. So volumetric efficiency is the ratio of actual flow rate of a pump to theoretical flow rate of the pump. It is a ratio of actual flow rate of a pump to theoretical flow rate of a pump. So volumetric efficiency mu V equal to actual flow rate of a pump divided by theoretical flow rate of the pump, QA divided by QT. So for gear pump, volumetric efficiency is 80 to 90%. Vane pump, the volumetric efficiency is almost equal to 92%. For piston pump, volumetric efficiency is equal to 90 to 98%. So the volumetric efficiency of the piston pump is very high when comparing to gear pump and vane pump. Next one is mechanical efficiency. It is a ratio of the pump output power, assuming no leakage, to actual power delivered to pump. See, during the working of a pump is connected to prime mover, that is electrical motor, by a shaft. So mechanical efficiency mu m is defined as that it is a ratio of pump output power assuming that no leakage to actual power delivered to the pump. So mu m is equal to pump output power assuming no leakage divided by actual power delivered to pump. So mechanical efficiency commonly 90 to 95 percentage. So the equation which is used to find out the mechanical efficiency is PQT divided by TAM. P is the pump discharge pressure in Pascal. QT is the theoretical flow rate of pump in meter cube per second. TA is the actual torque delivered to pump in Newton meter. N is the speed of the pump in radian per second. Okay, so this is the equation which is used to find out the mechanical efficiency of a pump. See, the mechanical efficiency can be also defined in another manner, that is, it is a ratio of theoretical torque required to operate the pump divided by actual torque delivered to pump. Theoretical torque required to operate the pump divided by actual torque delivered to the pump. TT divided by TA. So theoretical torque required to operate the pump is equal to Vd by 2 pi into P. Vd means volumetric displacement by 2 pi into P. P is the pressure. So TA actual torque delivered to the pump is P by N, power divided by N. So TT is in Newton meter, Vd is in meter cube, P is in Pascal. So this is the mechanical efficiency. Next one is overall efficiency. It is a ratio of actual power delivered to the pump to the actual power. It is a ratio of actual power delivered by the pump to the actual power delivered to the pump. So overall efficiency is the ratio of actual power delivered by the pump. Actual power delivered by the pump to the actual power delivered to the pump. So actual power delivered by the pump divided by the actual power delivered to the pump. Overall efficiency is equal to mu V into mu M. That means QA by QT into PQT divided by TA into N. Volumetric efficiency into mechanical efficiency is the overall efficiency. Okay. So these are three pump performance, that is volumetric efficiency, mechanical efficiency and overall efficiency. Okay. So next one, there is some problems regarding the mechanical efficiency, overall efficiency and volumetric efficiency. I am skipping this portion and leaving you as a self study. So these problems are not much important, but you have to go through this problem. There's a chance that it will be asking. So I am skipping these problems being time, and you can make it as a self study. There are 5 problems will be there, almost 5 problems will be there. Okay. So you have to go through these problems. There is a chance that it will be asking for examinations. So next one, factors considered for selection of a pump. So what are the factors that will be considered for a selection of a pump in a hydraulic circuit? So first one, capacity of pump. It should be capable of pumping required quantity of water. Second one, reliability. It should be reliable and should not fail suddenly and cause trouble. Cost. It should be cheap in initial cost. Fourth one, power. The power which is used for running pump should be available easily at low cost. Maintenance. Maintenance cost of running pump should be as small as possible. Sixth one, depreciation. It should have a long life and depreciation cost should be small. And seventh one, efficiency. Pump should have high efficiency. Eighth one, cost of labor. It should be low. Ninth one, number of pumping unit required. total lift of water required, and quality of water to be pumped. So these are the 11 points which will be considered while selection of a pump in a hydraulic circuit. Once more, first point capacity of pump, second reliability, third cost, fourth power, fifth maintenance, sixth depreciation, seventh efficiency, eighth cost of labor, nine number of pumping units, 10 total lift of water required, 11 quality of water to be pumped. Okay. So we are moving to next topic, that is hydraulic pressure intensifier. This is a very important topic. In this topic, I am going to discuss about what is the purpose of a hydraulic pressure intensifier in a hydraulic circuit, and what are the classification of hydraulic pressure intensifier, and what is the application of a pressure intensifier, hydraulic pressure intensifier. So first of all, what do you mean by a hydraulic pressure intensifier? So hydraulic pressure intensifier is a mechanical device which is used to intensify the pressure of a hydraulic oil to certain value, or increase the pressure of a hydraulic oil in the hydraulic circuit to a higher value that provided by the pump. Once more, hydraulic pressure intensifier is a mechanical device which is used to intensify the pressure of a hydraulic oil to higher value that of provided by the pump. So the pump will provide a hydraulic oil with a certain pressure. So the hydraulic intensifier that will boost the pressure of the hydraulic oil to higher value that of pump will be providing. So hydraulic intensifier, it is also known as pressure boosters. It will boosting the pressure to a higher value. So hydraulic intensifier always take low pressure, high volume of hydraulic oil, and which is converted into high pressure, low volume of hydraulic oil. Hydraulic intensifier take high volume, low pressure hydraulic oil into convert it into low volume, high pressure hydraulic oil. That high pressure hydraulic oil that will be utilized by the hydraulic circuit. See, there are two type of hydraulic intensifier. First one, single acting intensifier. Second one, double acting intensifier. These are two classification of hydraulic intensifier. First one, single acting intensifier, and second one, double acting intensifier. So first of all, I am going to discuss about single acting intensifier. So this is the figure of single acting intensifier. Okay. So single acting intensifier, before moving to intensifier, you should have kept in mind that intensifier, which is used to intensify or boosting the pressure of the hydraulic oil to a higher value that is provided by the pump. So it is boosting the pressure of the hydraulic oil. It convert high volume, low pressure hydraulic oil into low volume, high pressure hydraulic oil. So single acting pressure intensifier, this is a schema diagram of a single acting pressure intensifier, which consists two chamber, a low pressure chamber and a high pressure chamber. See, in left side, this is low pressure chamber with a large area, and this is high pressure chamber with a small area. So here the hydraulic oil will be coming through here and filling this low pressure chamber. So this is the high pressure chamber. This is the low pressure chamber. Note this, here there is no hydraulic oil will be there, and this is the high pressure chamber. Okay. So during the working, from during the working, hydraulic oil that flow to the low pressure chamber. Large volume of hydraulic oil with the low pressure is flowed to the low pressure chamber, and which exert a pressure over the low pressure piston. Low pressure piston have large area. due to this pressure, the piston will move forward. So there is a piston rod. Other end of the piston rod, there is a small piston, a small area piston in the low pressure chamber. So when this piston is moving, the small area piston also moving in the low pressure chamber, which will exert a pressure over the hydraulic oil here. So there will be large force will be acting over the hydraulic oil as the area will be very less. So the hydraulic oil pressure will be increased. That high pressure hydraulic oil is used by the hydraulic circuit. Once more, this is single acting hydraulic pressure intensifier which consists two chamber, a low pressure chamber and a high pressure chamber. So this is a low pressure chamber. Into this chamber, high volume, low pressure hydraulic oil is flowing into, and this is high pressure chamber. Here, low volume, high pressure hydraulic oil is created. So from pump, initially from pump, a low pressure, large volume hydraulic oil flow into this low pressure chamber, which exert a pressure over the piston. Piston have a large area. The piston will move in forward direction. So when the piston will move in forward direction, the piston is connected to a piston rod. Other end of the piston rod is connected to the low pressure chamber piston. So when this high pressure chamber piston, when the low pressure chamber piston moving in forward direction, the high pressure chamber piston also moving in forward direction and exert a force over the hydraulic oil, and the hydraulic oil get pressurized. That high pressurized hydraulic oil flow into the hydraulic circuit. So this is the working of a single acting pressure intensifier. Next one, what is the application of a single acting pressure intensifier? So this is the hydraulic press circuit in which we are using a pressure intensifier, single acting pressure intensifier. So the main components are, starting from bottom, we have hydraulic reservoir, hydraulic pump, pressure relief valve, 4x2 lever actuated DCV, then pressure intensifier, single acting cylinder, and this is the punch and off. Okay. So during the working, initially when the port P is connected to PA and B is connected to T. So the hydraulic oil from the pump flow through port P to A, and the hydraulic oil that flow to the low pressure chamber. From this low pressure chamber, the hydraulic oil exert a pressure over the large area piston. Due to that pressure, the piston will move forward direction. At the same time, in high pressure chamber, the piston that will also move in forward direction and pressurize the hydraulic oil. That hydraulic oil is flow to the single acting cylinder and producing the necessary work output. When the lever is shifted to next position, the port P is connected to port B and port A is connected to port T. So high pressure hydraulic oil that will exert high pressure hydraulic oil that will exert pressure over this side of the large piston. So the piston will move backward direction. At the same time, in high pressure chamber, the piston is also moving in backward direction. The spring exert a force over the piston in the actuator, and the piston will move in upward direction. The hydraulic oil that will be returned to the high pressure chamber. So this is the application of a pressure intensifier. This is the application of pressure intensifier, single acting pressure intensifier. See, while I am discussing this single acting intensifier, I have told that here is no hydraulic oil. Actually, here will be hydraulic oil will be also present here. Here and here also hydraulic oil will be present. Here there is no hydraulic oil will be there. Okay. So in forward motion of the piston, the low pressure hydraulic oil will be filling here. At the same time, there will be hydraulic oil will be here. That will be flow through to the reservoir. For return motion, the pressurized hydraulic oil from the pump is flowing to here and pulling the uh, low pressure piston in backward direction. So that's happening here. Here you can see that. So uh, for moving the actuator in downward direction, port P is connected to port A and port B is connected to port T. So hydraulic oil from the pump flow to the low pressure chamber. This is the low pressure chamber. This is the low pressure chamber. Okay. This is known as low pressure chamber. And exerting force over the low pressure piston. When the force is exerting over the low pressure piston move forward direction. At the same time, the piston in the high pressure chamber also move forward direction and pressurize the hydraulic oil. During the return stroke, A is connected to T and P is connected to B. Then what is happening? The hydraulic oil from the pump that is flow to the low pressure chamber here, and it will exert the hydraulic oil exert a pressure over the low pressure piston moving towards left direction, not right direction, left direction. Same time, the piston in the high pressure chamber also moving leftward direction. Then the return stroke will be taking place. Okay. So this is a symbol of a single acting pressure intensifier. So the intensifier that is connecting between the pump and the machine. Machine means actuator always. Okay. Next one is double acting intensifier. So double acting intensifier, this is the figure of double acting intensifier. Double acting intensifier, in both sides, the high pressure hydraulic oil will be produced. So totally you can see that 6 pipe connections, 1, 2, 3, 4, 5, 6 pipe connections. So if you required highly pressurized hydraulic oil in the left side here, through this port hydraulic oil will be enter from pump. Then the hydraulic oil that will exert a pressure over here. So low pressure chamber piston that will be moved towards leftward direction, pressurize the high pressure chamber hydraulic oil here and producing high pressure hydraulic oil in the left side. If we require to produce high pressure hydraulic oil in the right side, the hydraulic oil from the pump flow to this low pressure chamber in this side, that is low pressure chamber left side. Low pressure chamber have right side and left side. So if we require to produce a high pressure hydraulic oil in the right side, hydraulic oil from the pump that will flow to the left side of the low pressure chamber, exert a force over the low pressure piston, and the low pressure piston move towards right side. The hydraulic oil in the low pressure chamber get compressed, pressurized, and high pressure hydraulic oil will be produced. So this is the working of a double acting hydraulic intensifier. So this is the figure of double acting hydraulic intensifier. Symbol of double acting hydraulic intensifier. Then we have working of the double acting intensifier. So this is the working of double acting intensifier. So in both side, high pressure hydraulic oil will be produced. So if you require to produce the high pressure hydraulic oil in right side, hydraulic oil from the pump flow to the left side of the low pressure chamber, exerting a force here. The low pressure piston that will be moved towards right side and pressurizing the hydraulic oil in the high pressure chamber. If we require high pressure hydraulic oil in the left side, the hydraulic oil from the pump flow to the right side of the low pressure chamber, exerting a force over the piston. The piston moved towards left side, pressurizing the hydraulic oil in the high pressure chamber in left side and producing a high pressure hydraulic oil in the left side. So both side we can produce the high pressure hydraulic oil. Okay, so this is the working of a application of double acting intensifier. So these are all about intensifier. So we can conclude this section. So last section I have discussed about the intensifier, pressure intensifier or boosters. which is used to intensify the pressure of hydraulic oil to a higher value that will be coming from pump, which will boost the pressure of the hydraulic oil. So we have single acting hydraulic intensifier and double acting hydraulic intensifier. Okay. So today we have discussed about performance characteristic of post displacement and non-post displacement. Then some performance parameters, overall efficiency, mechanical efficiency, volumetric efficiency. Then some problems related to these parameter. I have skipped that portions. Then pressure intensifier. This pressure intensifier is very important. You have to study what is the use of a pressure intensifier in a hydraulic circuit, what is single acting pressure intensifier, what is the application, double acting pressure intensifier, and you have to understand the application. Thank you.